this is the real-time rows, and we're dealing with an optimization problem, right? We have a rectangle with a known perimeter, and they say, what's the greatest area that it could possibly have? So a rectangle of known perimeter obviously could have several areas. There's a rectangle of known perimeter that looks like this. If you take that same amount of fencing, if you will, and you build it into a rectangle like this, that rectangle will have a different area, even though it has the same amount of perimeter. So the first thing you want to know is, how do we optimize for largest area? What type of rectangle has the largest area? And this comes up enough on the ACT, you probably want to just know that the square is the rectangle with the largest area. Right? So the more eccentric you get, the closer you get to just being like a super long, skinny rectangle, the smaller the area gets. And you know that's true because if you ever go down to 0 on one of those sides, like the rectangle will pop out of existence and have 0 area. So the maximum needs to be where the sides are the same length. Right? If you're not convinced by what I'm telling you, either just memorize that or Google a proof for this, and there'll be several interesting things that you can look through. We don't have time to go over it here. So you need to just know that. So we know the perimeter is 52. So 52 divided by 4 will give us the length of a side, right? Which is, 4 goes into 60 15 times, 14, 13. So this is equal to 13. That's the length of a side. The greatest area that it can have is 13 times 2, or sorry, 13 squared is the area, right? Side squared. So the area equals 169. And all of this is in meters. So you can push that meter around if you want. Or you can just leave it out.